Here's what I want to look at. Now, what happens if we're given, we looked at the other day how to do things like graph, stuff like this. What if we had, for example, y is greater than or equal to 2x squared minus 3x plus 5?
I don't know. Hi, peoples.
We talked about how to do this. It's no big deal. This is, it's just like the stuff we did with graphing linear inequalities, only the boundary line is not really a line. The boundary envelope now, instead of being a line that separates two half-planes like we had in the past, is a parabola, right? So we end up with this parabolic boundary, and then we test a point, and we don't really know exactly what this is going to look like, but something sort of like that, let's say. We've got this boundary. We'll test a point inside or outside. We want to make sure we pick one, remember, that lines up with the vertex, vertically with the vertex, so we can tell easily if it's in or out. Let's just say, hypothetically, we pick this point right here. We pick one that's higher than the vertex. And we know how to find the vertex, right? This is in standard form, so we could do, the x-coordinate of the vertex, which we could call h. Whoops, is negative b, sorry. Over 2a. We could find what the x-coordinate of the vertex is. And that's really what we need, so we can line this thing up with the x-coordinate, right? And then to find the y-coordinate, we would just plug that value back in for x and find the y-coordinate. So we could know where the vertex is. And we know that because a is positive, it opens up. So we'll just pick this point either above or below the vertex and see if it makes the inequality true. If it makes the inequality true, then we'll shade that side. So we shade everything inside the parabola. If it didn't make the inequality true, I would shade the other spot. I would shade outside the parabola. Okay? So that's what we talked about late last week. And you'll have inequality as a good option for you also in your graphing calculators to graph these things. But what do you do if we have a little bit of a different kind of a problem? What if we have a problem that looks, something like this? What if we had, say, how about x squared minus 2x minus 24 is less than or equal to 0. Okay, now that's a little different proposition. That time, we don't have two variables there. We're not trying to graph this thing. We're trying to solve for the values of x that make it true. Okay, this one can be a little tricky. There's different ways you can look at this, but I'm pretty convinced that the easiest way to do this is to connect this quadratic expression to what we know its graph, or at least a sketch of its graph, would have to look like. Okay, now, we know that if I were just to take this part, it's in standard form, so 0 is on the other side. If I just take this quadratic expression on the left side, and let's imagine that as a function instead. Because really, when I write a quadratic function in the form y equals x squared minus 2x minus 24, it's the equation or the formula that's producing the y values, right? I feed this thing x values, and it gives me back y values, right? Now, what would a sketch of that thing look like? Does it open up or down? Opens up. And the sketch we're going to make now doesn't even have to be remotely accurate. All we really have to know is, does this thing open up or down? Well, it opens up because a is positive, right? So we know it's going to have this kind of a look to it. Okay, well, we're trying to find here in this inequality, we're trying to find the values of x that make this whole quantity less than or equal to 0. Okay? But remember that this whole quantity over here, this whole quadratic expression, is just giving us back the y values, right? Now we know that the y-axis is the vertical axis. So if I were to put some axes on here, and I don't know if these are in the right places or not, I don't really have to know. But I know that y is a vertical quantity. I would so strongly encourage you to watch this, because if you don't, this is not, like I say, it's really not in the book, and This is the section that people typically have the hardest time with in the chapter, I think. It's not a big section. I mean, if you concentrate now and you get it, I think you'll be fine. But if not, I'm just telling you, I don't think it's likely you're going to be successful with this. So the best advice I could possibly give you is put everything away that could possibly distract you and really focus on this. You can choose not to, but it's just not a good choice. This is giving us back y values. Now, what we essentially want to know then is if I were just to call this y instead of that quadratic expression, it would just look like this. Y is less than or equal to 0. Now, where would that happen? Where are y values less than 0 in the coordinate plane? If I take a picture of the coordinate plane,
And you think that's negative?
well, what do you mean negative? If I break the coordinate plane up into quadrants, there's quadrant 1, there's quadrant 2, there's quadrant 3, and there's quadrant 4. I want to know where is y less than 0, less than or equal to 0. Let's say you say less than 0. Does that make sense? Because that's going to be places, if this is the y-axis, the vertical axis, it's only down here, right? This is the place where y is going to be less than 0. Where does y equal 0?
The origin.
Not just the origin. I think somebody said it.
Or the x-axis.
The x-axis, sure. Y equals 0 every place on this line right here, doesn't it? That's where y equals 0, right? So now if I go back to this problem and I'm trying to find the places where the y values that we calculate from this function, it looks like a parabola when I graph it. If I want to find the places where y is less than or equal to 0, where on the parabola is that going to be? Let me do something here. I want to get rid of that. Yeah, it's going to be, isn't that going to be, oops. Oh, I don't want it either. That's what I want. If that's the x-axis, and I don't know where the x-axis is. I don't even know if the parabola intersects it, but if it does, where is this going to be true on the parabola? Where are the y values less than or equal to 0? Is it up here?
No, it's below.
Is it right there? Yeah, if an ant is walking along this parabola, where could he say for sure that he has y values that are negative?
Below the x-axis.
Yeah, down here in the loop, right? The place is where he's standing below the x-axis. That's where y is less than 0, right? So if we want to look at this, break this into two parts. If we want to break this into a y is less than 0 part, well, that's going to be down here, isn't it? Those are the places where the ant could stand on that parabola so that his y value is less than 0. Now, what about the equal to part? Well, I don't want that color. I already got that color.
You're including on the x-axis.
Use that color. Yeah, that's going to be the place directly on the x-axis, right? So those are going to be at those spots right there and there, right? So taken together, the places where this is true, where this parabola, if I think of it as a function, where that parabola is on or below the x-axis, is going to be down here. It's going to be it's going to be at or between the x-intercepts, or the zeros of this thing, right? So all I've got to do, if I can find out what these are, I mean, I could even just call this one right here x1 and that one x2 or something for now. Or maybe even better than that, how about if I just call them like, well, that's fine, x1 and x2. If I call them that, then I'm looking for the x values that are pinched in between x1 and x2, right? That's my answer, isn't it? Those would be the x values that would make this expression negative or 0. Okay? So all I've got to do is solve that. It is find out where those are. Well, to find out where those are, the boundaries are the actual points where the function crosses the x-axis. So I don't have to worry about the inequality anymore. I can just solve the equation instead. So let's do that. So if we want to just look at the equation part then, I can just replace this whole thing with x squared minus 2x minus 24 equals 0, and we're pros at that. That's what we've been doing for a long time, and you guys are getting really good at that. How would I solve this one most easily? Not FOIL. I think you're thinking the right thing, but you're not saying the right thing. I mean, I could always use a quadratic formula, but I want to see if I can do something more easily first.
Isolate this.
Well, I can't. I've got x squareds and x's. But if I can, because I've got a 1 in front of the x squared, we always want to try to do this. See if I've got some magic numbers that work. They have to, if they exist, they have to multiply to what? Negative 24. And add to, what would those be? Yeah, negative 6 and positive 4. So then what are the solutions? If I set those factors equal to 0, I either get x equals 6 or negative 4. Now I didn't draw this sketch right, did I? But that's really not the point. I know that negative 4 would be the one on the left, so this x1 is really equal to negative 4, and x2 is really equal to 6. And my solutions are just going to be x is greater than or equal to negative 4 and less than or equal to positive 6. Okay? Let's try another one of those. That first time through, I know there's a lot of stuff going on, but once you see one, we just go through one like you would in the problem set. It's not that much stuff. Okay, let's try this one. How about solve How about that one? No, I don't, not equal, so I want to do an inequality. I want to do greater than or equal. Okay, what do I have to do first? Like always, if I'm solving a quadratic equation, what do I want to do first? Good, get it equal to 0. Very good. So we're going to push everything left, right? So I'll add 4x. And I'll add 4. And I end up with x squared plus 5x plus 6 is greater than or equal to 0. Right? Okay, so now I want to think about this, remember. I want to think about this parabola that I'm making if I graph this. So I'm imagining now, or I can write it down if I want to. I want to take the function, make this y instead. Y equals x squared plus 5x plus 6. Right? That's what I'm graphing. And I want to know then the y values, because that's what this is generating. I want to know where the y values that this generates are greater than or equal to 0, right? Okay, so what kind of a parabola sketch would I make for that? Does it open up or down? Opens up. Well, the way I always do this is I just go like that, and I just put a line through the middle that represents the x-axis, just to help me get my bearings. Okay, now let's interpret this part over here real quick. What does all this stuff mean? If I just take everything inside the box, I've got this parabola. I want to know when are the y values what? Greater than or equal to 0. Now, what does that mean in terms of where the ant's walking on the curve? If I look at it's going to be above or on, right? Does that make sense? The equal part, the equal 0 is on the x-axis, and the greater than is above. So if I wanted to translate this into words, and this is important, this symbol right here becomes on or above, and then I guess this is really just telling us the x-axis, right? Those are the places where we're looking. Now, where is that going to be? If I had to shade those in on the function, where on the function would the ant be on or above the x-axis? Where would the parabola, the y values, be on or above? If I had to just sketch it. It's always going to be one of two choices. Either it's going to be the loop, which is between the two x-intercepts, or it's going to be the tails of the function, which are outside. Which one is it in this case? Yeah, wouldn't you agree that either here or here, those are the places where the ant's above, right? And he's on right there and right there. Make sense?
Yep.
So all I've got to do then, I can see graphically where that happens. I just want the x values that make that true. Well, that's going to be happening. All that stuff's going to be happening. The ant is going to be, the y values are going to be on or above when the x values are either less than, call this, I would call it A, for example. It's either less than A or equal to, or x is greater than or equal to, if we called that B. We just need to know what those things are, right? We just need to know what the x-intercepts are, right? But that's my answer. I know what my answer is going to look like. My answer is going to look like x is less than or equal to that number, or x is greater than or equal to that number. Guaranteed, that's my answer. But just what are those numbers? How do I find out? Yeah, just I want to know, I want to set this thing equal to 0 to find out where the x-intercepts are, where the boundaries are, right? So we'll take our original inequality and we get to replace it with something easier with an equation, right? So let's solve that then. We've got the equation x squared plus 5x plus 6 equals 0. Okay, I could always use the quadratic formula. It'll always work. But does it factor?
Yes. 3 and 2.
Yeah, two numbers that multiply to 6 and add to 5 would be plus 2 and plus 3. So then if I set the factors equal to 0 to solve for the zeros of the x-intercepts, what do I get? -2 or -3. So now I know what those places are. This one is at -2, and this one, or -3, sorry. And this one is at -2, right? And so my answer is just either x is less than or equal to -3. Does everybody see what I mean by that? We want the x values where this is happening. So if this is the place up here, this is the left tail of the function, this is one of the places where the ant's y values are big, or positive. What are the x values? What are the x coordinates of every point up here? Wouldn't you agree that if I were to drop these straight down to find out what the x values are, they're all going to be to the left of that boundary?
Yeah.
Right? If you don't have to do this, but sometimes it helps to think of the shadow that the function casts on the x-axis. When you're looking for the x values, just imagine that someone's shining flashlights up from the top and the bottom. Where is that part of the function casting a shadow? Well, the shadow of this left tail is going to be out here, isn't it? Here's going to be the shadow that it leaves. Right? The shadow of this part over here, the right tail, is going to be over here. Right? So either x is less than or equal to -3, or x is greater than or equal to -2, right? And if I looked at this inequality, sure enough, it looks like the oar's on the boat, doesn't it? Right? Make sense? An ant can't be here and here at the same time. He has to either be to the left of that point or to the right of that point. It's always, you're going to notice this too. It might seem at first like there's all these possibilities, but there really aren't. You know that if your answer on your sketch ends up being the tails of the function, that's an OR statement. It has to be. If your answer ends up being the loop between the x-intercepts, that's an and statement, because those are x values that are pinched between two endpoints. Okay? Why don't you just try one of these? I want to just make sure everybody can do, regardless of where you are in the chapter, just try one of these and let's see if we can't get one to work. You can work with a neighbor if you want it. Take this one, how about, let's see. Now, if you had a graphing calculator, it'd make this pretty easy, wouldn't it?
Yep.
Because you could just, instead of having to sketch the parabola, you could just graph it, right, and look on the graph, and you could even find the x-intercepts that way. Okay. First, I want you to try one like this. Okay, try that, please.